Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering, and the subject is CS3492 Database Management System. The unit is Implementation Techniques. The topic is Heuristic based query optimization. In general, many different relational algebra expressions and hence many different query trees can be equivalent. That is, they can represent the same query. The query parser will typically generate a standard initial query tree to correspond to an SQL query without doing any optimization. For example, if for a select project join query such as Q2, the initial tree is shown. The Cartesian product of the relations specified in from class is first applied, then the selection and the join conditions are applied, followed by the projection on the select class attributes. The heuristic query optimizer will transform this initial query tree into an equivalent final tree that is efficient to execute. The optimizer must include rules for equivalence among relational algebra expressions that can be applied to transform the initial tree into the final optimized query tree. First, we discuss informally how a query tree is transformed by using heuristics, and then we discuss general information transformation rules and show how they are used in algebraic heuristic optimizer. First is the break up the select operations with conjunctive conditions into a cascade of select operation. Using the commutativity of select with other operations, move each select operation as a far down the query tree and it permitted by the attribute involved in the select condition. Using commutativity and associativity of binary operation, rearrange the leaf nodes of the tree. Combine a Cartesian product operation with the subsequent select operation in the tree into a join operation if the condition represents a join condition. Using the cascading of the project and commuting of project with the other operations, the breakdown and move list of projection attributes down trees as far as possible, creating a new project operations as needed. These are some of the steps involved in the heuristic query optimization. Next, cost component of query execution. The cost of executing the query includes the following components. First one is the access cost to secondary storage. Next one is the storage cost. Then third one is the computation cost. Fourth one is the memory users cost. Then fifth one is the communication cost. The importance of access cost. Out of the above 5 cost component, the most important is the secondary storage access cost. The secondary storage access cost means the emphasis of the cost minimization depends on the size and type of the database applications. For example, in smaller database, the emphasis is on the minimizing computing cost because most of the data in the files involve the query can be completely stored in the main memory. For large databases, the main emphasis is on the minimizing the access cost to secondary device. For distributed database, the communication cost is minimized because many sites are involved in the data transfer. Cost functions for the join operation. Join operation is the most time consuming operation to process and estimate for the size that means number of tuples of the file that result after the join operations is required to develop reasonably accurate cost function for join operations. The join operations define the relation containing tuples that specify a specific predicate f from the Cartesian product of two relations R and S.